Hello and welcome to Beamer Folk.
I thought I'd have a little chat about prototyping. I'm now an electronics hobbyist. I used to do this professionally, but I have a rather different perspective now. And all things tend to start, of course, with an idea, and an idea, before it crystallizes into some formal structure, goes through a number of phases of adaptation and changing, adding various features, removing various features, finding out what's useful, what's not useful, what works, what doesn't work. And we all tend to start off with a breadboard, and that offers the ultimate in flexibility, but it suffers badly from reliability and intermittency. Furthermore, there are issues with resistance and capacitance of the various pin positions and locations. So the circuit implementation you might be thinking about could be at quite high frequencies, and a breadboard suffers from those issues. If you need to pass a bit of current through it, it doesn't like it. You can't really push it more than half an amp or so, because the voltage drop across the lines becomes significant and interfere with your circuit and idea. But nevertheless, it actually is extraordinarily flexible and useful within its known limitations. Now, to move on from a breadboard, you can go, if you're wealthy, immediately into a printed circuit board implementation. And I'll just shift that delicate affair over and bring into view a printed circuit board. Let me zoom a bit into there. It's a bit distant, isn't it? Very well, I'll try that. Okay, so you can use a printed circuit board, and you can buy these inexpensively from abroad, from mainly Asia, really cheaply. But I've found that it kind of doesn't have the flexibility that I like, in the sense that if you make minor alterations and add various features and applications, so if you're prototyping still fairly low down the level, you haven't got a finished implementation of what you're thinking about, then this idea can get a bit expensive. It doesn't appear to be expensive, it looks quite cheap, but by the time you've paid for the postage and packaging, this particular board I've got here, which is a double-sided board, which I purchased some years ago now, turned out to be, by the time I'd finished, about £30. Well, unless you're very wealthy, you can't keep doing that for every time you make a change or an adaptation to the circuit whilst you're prototyping. If you were a commercial company, you wouldn't be concerned about this at all. But from a hobbyist perspective, I find that I like the idea of a printed circuit board, but I really want to firm up on my idea before I go to a printed circuit board. So I want an interim stage between a breadboard and a printed circuit board. And in many circumstances, you don't actually need a printed circuit board, but I find I like to finish a product with a printed circuit board, or an idea, I should say. Hark at me going back to a product, but finish an idea with a printed circuit board. But from the breadboard, I tend to want to move to either a perf board or a strip board. My preference is actually a strip board, or the branded name I think is Veroboard, and let me show you what I mean by that. And here is a Veroboard prototype that I'm in the process of constructing. It uses this type of board. I'm not quite sure whether it's paper or what, but the only thing I will say with this is that this material is not flame retardant, so it wouldn't be acceptable within a finished product if you were selling a product, selling your idea. It's really only of value to people like myself, which is a hobbyist, or as an interim measure between the breadboard and a printed circuit board. Printed circuit boards, incidentally, by design, are flame retardant, and that's one of the reasons why we use them. Now, I find a strip board to be extraordinarily versatile. Not quite as versatile as the breadboard, but pretty close, because you can adapt it, you can adjust it. The time it takes to put a fairly complex idea onto, and it's surprising how much you can pack onto a strip board, and you tend to operate the strip board as tracks going, in this case horizontally, in that direction, and on the other side, as well as the components, you tend to have many links that do the vertical plane. So there is great flexibility within this system. What's more, if you feel as though you can develop your idea further, you can literally chuck that away and get another one. The cost of this particular board here in front of us is about £1. It is true that you have to spend a day in working out the location of the components, optimizing that. You do have to, and there is a superb piece of software to do this called DIY-LC, and I'll put a link to that in the comments below, and that's superb. But you will spend a day doing this. Well, if you're thinking about a printed circuit board, you might say to yourself, well, that's a waste of time spending a day on a strip board, when in fact you can spend that day on designing a printed circuit board. But in my experience, the printed circuit board software takes a bit of a learning curve to get right, and you do have to be very disciplined over the files that you submit to the supplier of the printed circuit board. And of course today that's all transmitted over the World Wide Weird. So you've got a bit of complexity, and the day that you may have spent on working with a strip board actually gives you, as to if you're progressing to a printed circuit board, it gives you a good idea as to what are the total number of components for the board and their locations, their optimum locations. So in many respects, a printed circuit board can kind of mimic what you did within a strip board. When using strip board, as well as the horizontal and the vertical, and in this case you've got horizontal tracks with vertical links, there's also enormous flexibility added to this circuit, and this is how you can pack an awful lot of components into this small area, surprisingly so, is that the controls for doing that are cut pieces within the track. Now I use a 4.5mm diameter drill to actually drill the cut, and that improves the density of components enormously, and that's the reason why I like strip boarding as a prototype. Now in this particular case, as you can see, there is a large notch corner piece taken out of the strip board here, and there's a small piece here as well. Well, in this section here I've got an op-amp, and the stock op-amp that I'm intending to use, that I've actually got, is not quite good enough. I need to do some more research to get a better op-amp, and instead of having to when I eventually change the op-amp to a better op-amp, instead of having to completely rebuild this circuit, what I've done is I've effectively made a notch out here, a corner out here, so that for the meanwhile I can use my stock op amp by, in fact it's that way around, isn't it? Silly me. That way around. So by putting wire links between here and along there, maybe about 8 of them, to connect up to the main board, I've created a daughter board, and on that daughter board is the output op amp that I've got stock, and I'll use that as an interim basis until I've done more research to find a better op amp. And when I do find a better op amp, all I need to do is throw that out and create another one with the new op amp in place. Okay, so what tools do you need to construct a Stripboard prototype? Very primitive really, and I've not really found an improvement to them. I've been doing this now for, well, 60 years, and I haven't really changed. I haven't found a better tools to do this than the one I use. One is a grandfather drill. You might think that's rather quirky in today of Dremel drills and the like, but this old grandfather drill, you don't need, for example, on the cutouts, the drill cutouts, you don't need many turns of the drill bit to create the cutout. And in fact you can over cut out, you can under cut out as well. But if you over cut out, you can actually cut into the adjacent track. If you undercut, you can still retain a link between the two separated tracks, so therefore there would be a short circuit. So you need very good control over the drill, and I found no better drilling tool than an old grandfather drill. And this one I've had for 40 years and it's still going strong. A little bit of oil now and again, but it works. The other thing is that you need, when you're drilling out the drill cutouts, you need the board to be in a stable locked position. You can use a vise for that, but I found I prefer something a bit simpler, and what I use is a G-clamp. The G-clamp, this one here I've had for about 50 years, and it does exactly what I need. What else is required? Well, you could do with a continuity checker, electronic, a modern electronic voltmeter, just to make sure that when you do a drill cutout that there's no remaining track between the two adjacent tracks. And the way you do that is you buzz that out, and if it buzzes you haven't quite drilled it out far enough. And so each drill cutout needs to be tested once you've done them all. On this particular board I've got about 70 drill cutouts to be done, and all those can be done in an hour, maybe less. In fact, I think probably 3/4 of an hour. So it's very simple to do. The actual where you drill the drill cutouts, I tend to use the software I mentioned earlier, the DIY LC, and through a little bit of manipulation of that superb software, by removing the components but leaving the drill cutouts behind, and then mirroring that image, you get the copper side on your computer, on your screen, you get the mirror image of all the cutouts that you need to make. And then what I do is I use a felt tip to literally dot each position, counting the X and Y's on each position of the track, laying a dot down and going through the track that way. And that's how I do it. The little cutout at the end here is to take a switch. It is a location for a switch, and I'm just getting the switch now to show you. And this is a 3-position switch with 4 tags on it, and it sits in that position there. Now this strip board is pitched at 0.1 of an inch, whereas the switch is pitched at millimetre size. So there's an incompatibility there. But if you, I don't know whether I can show this to you closely. Let's get it in focus. Make a cutout on the strip board to accommodate the switch so that it can be flush within the box, within my box. And I've cut out and drilled out the track so that it accommodates, so I can solder those pins onto a 0.1 pitch. You can see the track right at the middle. I've actually removed all the copper by using by drilling them out using my 4.5mm drill twice along there, and that removes the copper, and that should work nicely. So that's it. And what I do now is I'll go in and do a little bit of drilling of this strip board, so you can see how I do this. So you can see the strip board is now clamped down, G-clamped down, and I'll zoom in, demonstrate how I drill out the drill holes. Now I've got to kind of work around the tripod as well, but let's see how we get on. All you have to do is line up and just rotate there. One drill hole, another. Of course, the actual holes in the strip board act as a pilot hole, so I found with a 4.5mm diameter drill that it locates into the pilot hole quite well. If you use a slightly larger drill bit, it doesn't locate properly into the pilot hole. And all I'm doing, and you can see how quickly this is running along here. And of course the trick is to not make a mistake. Well, I suppose a mistake is inevitable at some stage. But you can easily put a little copper link over the top and get back to some. This is a bit close to the G-clamp, so I'm rotating around here, and you've probably lost vision of it slightly as well. Let's just, there we are. Let's carry on with this one over here. As you can see, it's so simple, isn't it? And I've done quite a few there. I'll do probably the rest later. When you've finished doing all the drill cuts on the board, it's worth washing it down, cleaning it off with methylated spirits. That's what we call it here. I'm not quite sure around the world what it's called. In fact, I think wood alcohol is another phrase for it. But it's worth washing off the board, and you get rid of then of all the felt tip markings and whatnot, and degreasing. And then finally, with a bit of emery cloth, just rub over the copper surface of the board in preparation to soldering. This actual piece of board I've had in stock probably for about 8 years, and the copper does oxide and you can't solder onto it quite as well. Okay, well, before I speak of the physical performance of this type of board, I'll just cut and break a piece of this board to demonstrate how easy it is to break the board into the shape and size that you actually wish it to be. What I've got is a little bit of board here, and I'm just going to cut it through. And I'm using what I know to be a Stanley knife, and so all you have to do is just line up with a Stanley knife and cut through. Do that a couple of times on each side, and you can see that I've actually marked where I'm cutting. If you don't do that, if you're not careful, you can cut one series of holes on this side and another series of holes on the other side, and it becomes a little disastrous in breaking it. But let's go from here to there. So now I'm cutting down a copper track side. Do that a couple of times, and I'll probably use one more here, and that's it. There we go. Right, so let's do that. Now that should actually break, and there we are. It's as easy as that. So okay, I just do a little bit more of talking about cutting. So if you come to a board like this, you can, with a Stanley knife, you can cut along a track like that to create this cutout. So the horizontal aspect of the bit that you want cutting out, you can do that with the Stanley knife. But if you were to do this as well and expect it to break off as a corner, it would end up by leaving a piece in the corner here. So the Stanley knife procedure is valid when cutting straight across something, but when you've got to cut out like that, it's not wise to try and use a Stanley knife on both the horizontal and the vertical. So what I tend to do is use a hacksaw blade, and cut, putting it into a G-clamp and cutting down this plane to the hole line that you wish to cut, so that this effectively is separated there. So all you then need to do is, with the Stanley knife, is cut along this horizontal, and then do that several times either side, and then biscuit break it like that, and then it leaves a very clean edge. And in fact, the edges, I tend to use a small file just to make sure that the edges are nicely deburred. When it came to this cutout here, again, because you've got both horizontal and vertical, you can't do that with a Stanley knife. So what I did is, with a hacksaw, is just cut the two horizontals here, and then with a Stanley knife cut across there and across there several times, and then with a pair of pliers just biscuit break that off. So that's that. So what is the performance of this board like? It's okay. As you can see, physically it's not actually very strong, and so therefore couldn't be really used in a final product going to the customer in a commercial way. It's okay. I have seen it in equipment where a company has just knocked up something very quickly to solve a customer's issue problem, but you try and avoid that. It's not very strong. It is okay, and as you can see, the way I broke that little board, you can see that its strength is not brilliant. What is its and you can strengthen it by using araldite and various other things, but in principle, if you're thinking commercially, go to a proper printed circuit board. So what's its electrical performance like? Well, between tracks, I wouldn't put more than absolute maximum 100 volts, assuming that it is a relatively high impedance. And in fact, actually, it starts to worry me beyond 50 volts. So that's its voltage. The current through these copper rails, tracks, I wouldn't really attempt, in fact actually 1 amp is probably a bit high, but I certainly wouldn't go beyond 1 amp, and if you were to put 1 amp through the copper track here, you would find that there is some not significant, but some voltage drop actually across the track. So I tend to keep it below, say, 100 milliamps, 200 milliamps at the most. You can increase, if you are building, say, an amplifier, you can increase the current handling capabilities of this track by soldering on, overlaying a piece of tin copper wire, and that drops the impedance of the track and increases its current handling capabilities. Frequency, well, Veroboard, I've personally not operated Veroboard at a frequency higher than about 1 megahertz. It's probably sound to about a couple of megahertz, and I have known people build radio receivers and transmitters with it and whatnot. But as the frequency increases, there's a small amount of puffage, a couple of puffage between the tracks. As you can see, the gap between the track is actually quite narrow. That can start to cause an effect as you increase the frequency. Of course, if you are frequency considering higher frequencies, you can actually remove one copper track, leaving a much larger gap between then the two adjacent tracks, and you can get some performance that way. But when you really start to consider high frequencies, it's far better to go to a solid piece of printed circuit board where you've got a consistent layer of copper, and you effectively etch out areas from that copper so that you get proper high frequency soldering connections, and then the frequency can go up. But for this type of stripboard, Veroboard, it is frequency limited. You need to bear that in mind. It's nowhere near as inferior as a breadboard, and it is surprising what you can build on this type of stripboard and get away with. But please bear in mind that there is this capacitance issue, and of course if you drill cut out parts of the track, then of course you are isolating a bit of track and you are reducing the adjacent puffage capacitance leakage between two tracks. I hope that's been of interest to you, and I look forward to seeing you again.
This is Beamer signing out for now.